Hey everyone, I'm sorry I'm missing class tonight, but if everything goes as planned, about this time right now, I'll be holding a brand new baby boy. I know my world's about to turn into its own web of complexity and chaos, but I wanted to take a second to explain an essential of complex living systems, and that component is dissipative structures. To me, the key to understanding dissipative structures is to realize that they maintain themselves far from equilibrium. The further a dissipative structure is from equilibrium, the greater its complexity and the higher degree of nonlinearity in the mathematical equations describing it. Now, what does that mean? Well, with linearity, we've all seen a straight line. Cuts across, it has one solution. We've probably seen quadratics, which is a second degree, that have two solutions. You may have even seen cubics, which have this snake shape and can have up to three solutions. So all that means is that nonlinear equations usually have more than one solution, and the higher the nonlinearity, degree 1, 2, 3, 4, 5, the greater the number of solutions. So to examine this, I want you to close your eyes, and I'm going to describe Ludwig Boltzmann's experiment to examine this concept of entropy and disorder. So go ahead and close your eyes and imagine 5 unique molecules swirling around a box. They could all be different colors, they could be numbered 1 through 5. But you've got all these molecules that are swirling around, and at any moment we could drop a line right in the middle of the box and count the number of molecules on the left versus the number on the right. Well, I went ahead and did this, and you can see here all the possible outcomes. We have 5 on the left versus 0 on the right, 4 on the left versus 1 on the right, and so forth. Now, if you've taken Kennedy's class, when you saw this graph, you probably realized a bell-shaped curve with the highest probability ones occurring right there in the middle. So let's look at this. Right here, we have a box labeled A, B, C, D, and E. Well, there's only one possible way we can have all 5 of these molecules on one side, and you can see it right here. Now, we can swirl it around and change the order, but there's still only one way to have them over here. Well, we can take one of these and put it on the left. Well, we could put A back and move B over, put B back and move C over, but basically what we're doing is we're leaving 4 on the left and 1 on the right. Well, there's 5 different ways that this can happen. Likewise, if we had 3 on the left and 2 on the right, and so on and so forth. Well, jumping back to the graph, you can see that 2 on the left and 3 on the right, or 3 on the left and 2 on the right, are the most likely to occur. So that means if we were to randomly shake up that box, most likely we would have 3 and 2. Well, if you look at the far left and the far right, these indicate 5 on one side and 0 on the other. Well, we already said there was only one way that that can happen. So the fewer the complexions or the fewer the arrangements indicate the highest order. Even if you look at this example using 10 balls, you can see that the highest complexions are right there in the middle with 5 on one side and 5 on the other. The fewest complexions have 10 on one side and 0 on the other. Well, what this means is that the graph is flowing from a state of order to disorder, one complexion to many complexions. But what is unique here is that the graph also flows from a highly unlikely event, just one occurrence, or 3% chance of happening in the first example, to a much more likely occurrence in the middle at the top of that bell shape, which is about a 63% chance of happening. And this is how probability is defined. The higher the number of complexions, the greater the disorder will be, and the more likely that event is to occur. These structures will tend towards a state of maximum probability, or most likely to occur, which is also a state of maximum disorder. So that's where we get this idea of chaos or complexity. The second thing I want to show you is to note that it's imperative to classify these living structures as open systems, to emphasize their dependence on a continual flow and change in its metabolism. which involves thousands of chemical reactions. So just like when you closed your eyes and you imagine those 5 molecules dancing around, well, that's what we have to do. We have to look at the times of maximum complexity. So they say that chemical and thermal equilibrium exists when all of these processes have come to a halt. In other words, an organism in equilibrium is dead. So let's look at this jar here of black sand, and we're going to add some white sand to the top of it. Okay? You can see the black sand at the bottom and the white sand at top. Well, some would say that this right here is equilibrium. The chemical and thermal equilibrium is said to have been achieved, but this living system is static. It's dead. And there's only one possible way for this to occur. Living organisms continually maintain themselves in a state far from this equilibrium, which is the state of life. So let's take this jar, or this life, as the life of a high school student who you are trying to teach and trying to understand how he or she learns. Well, we know that a lot of things can come up. The student might miss the bus in the morning. The student might leave their lunch money at home. The dog may have eaten their homework. Or the most likely thing to occur is, well, teacher, what had happened was, well, what you can see here is all of the white and the black sand are mixed throughout. This event right here is the most likely to occur. All of these different things in different scenarios take place with the student's life, so this is where we have to start from. This is where we have to look at answers. This is where chaos theory lives and where it thrives. This is where we have the most complexions, thus this is where we have the most disorder, but it's also the highest probability of occurring. So this is the framework or the chaos that we have to study and that we have to live.